Hi there. Um, so what we're going to do is we're going to use MDSolids to model a truss. And so we've kind of looked at this on Monday, maybe a little bit on Tuesday. So this is kind of to help you if you don't have any remembrance on how to do that. So you're going to have to make a new truss on a blue sheet of paper, and you have to solve it and go through and use your other blue worksheet that you had to help you, to solve for the reaction forces, to solve for the missing angles, to solve for our member forces, if they're in tension or compression. Um, so you have to make up a force you're going to apply to it. You have to make up a span and a height, and put that on a new blue sheet of paper. Solve it all, and then probably, hopefully by the end of Wednesday, you can submit this. Into a picture of your truss of MDSolids into Google Classroom, by the end of Wednesday or Thursday. So hopefully by Wednesday, but if you have to, finish it on Thursday with the computer, go ahead and do that on Thursday. So again, make sure you turn your blue sheet of paper into Mr. Branicar. So I've got a new truss, and what I like to do is I like to have an even number of spaces, and then I have a 1 as my interval. Okay, so that's what I've got. So I'm going to go ahead and create my members, and so I have a base from like A to D is 7. So I'm going from 1 to 8. 1, 2, 3, 4, 5, 6, 7. This is going to go up to 9, so it's going to go to 12. And then that's going to go and connect there. And then this part here is 8 units long. 8. All right. So my, inverse tangent of 9 opposite divided by 7 for my adjacent gave me 52.1, which is what I have here. And so then my inverse tangent of 9 divided by 8 gave me 48.4, which is what I have 48.366 here. So now I'm going to add my support. So I'm going to click and drag down, and I'm going to click and drag to the left here to make that a pinned support. And I'm going to add my force at D on my sheet of paper, but it's probably going to say that it is B on this one. Okay. So what I have, again, I've got to solve my reactionary forces. So again, I would have to take like 7 units for my base of A to D times this force here, so 600. So that would be 7 times 600 be 4,200 is equal to this distance, which is 15, times the reaction at C, which I don't know. So 4,200 divided by 15 is 280. So I have 280 at this point. So 280 subtracted from 600 is going to give me 320. So once I have those reaction forces, I can dump those back into like solving for member AB on this piece here, and that would be my 320 plus AB sine of 52.1 equals 0. So if I separate those and get the AB by itself, AB is going to be equal to negative 320 divided by sine of 52.1, which gives me 405.5 based on my rounding. So I'll compute it. And so again, on my blue sheet of paper, I have all the math to prove that these numbers are correct. So you got to have your blue sheet of paper filled out for Mr. Branicar, and you got to take a picture of this with your phone or somebody else's phone and have them send it to you or upload it to your computer to submit a screenshot of this into Google Classroom. All right. So that's what I've got here. So my math says that that's right. So I had my sheet of paper, I had 249 for my A to D or A to B on this one. So 248.89 rounds up, I suppose, to 249. Excuse me, it's 9 o'clock on Sunday, so I'm a little tired here. Hope you had a good Thanksgiving too, by the way. 374.4 is what I had for my B to C is what I called it. And I had another 248.6 for my D to C on my sheet of paper. So that just kind of proves, that you got the math idea down, where to put in the sine and cosine, how to solve that. Again, those pieces that are orange, those again are in compression, and the ones that are in blue are in tension. So again, we get a negative value for one of your members. That would be that we assumed that it was not correct to be assumed in tension. So hopefully this helps you, and make sure you submit this screenshot hopefully by the end of the day, Wednesday, but no later than Thursday at the end of that day's class. So thanks. Have a great rest of your week. Take care.